In the winter of 1514, deep inside the cathedral town of Frombork on the edge of the Baltic Sea, a middle-aged canon named Nicholas Copernicus sat hunched over parchment, illuminated by a single, wavering candle. Outside, snow covered the stones of the Warmian fortress, muffling the world to a hush. Inside, the scratching of his quill carried the weight of quiet rebellion. He was no fiery reformer, no preacher railing at pulpits, but a man of figures, charts, and the strange patience of those who believe truth can be proved with ink. By day, he tended church accounts, observed feast days, and served his bishop with the mild obedience expected of a scholar cleric. By night, he plotted the heavens. He had inherited from the ancients a cosmos neatly arranged, Earth fixed at the center, the sun and planets nested in crystal spheres, angels guiding them in perfect circles. It was elegant, divine, and wrong. Every month he watched Mars drift backward in its path, the so-called retrograde motion that Ptolemy's system explained with convoluted loops upon loops. Yet even those could not fit the numbers he recorded through his crude instruments. Something else was at work. The Church's astronomers called such discrepancies the imperfections of man, not of God's design. But Copernicus had begun to suspect the imperfection lay in the diagram itself. He imagined, tentatively, that the sun might stand still and the earth might move. The idea was not new. It had been whispered centuries earlier by Greek thinkers. But in Christendom, where Scripture said the world was fixed, to assert it openly was to court ruin. So Copernicus concealed his notes behind polite Latin and vague diagrams, sharing them only with a handful of trusted correspondents. They called his model mathematically convenient, nothing more. Still, each night he returned to his table, recalculating, adjusting, erasing, until the pattern revealed itself. With the sun at the center, the numbers finally made sense. In that discovery there was both terror and exhilaration. The terror came from faith itself. If the earth moved, then all Scripture describing a steadfast world would need rereading, and men of the cloth did not reread easily. The exhilaration came from the beauty of consistency. Where others saw danger, Copernicus saw symmetry. Yet he understood the climate of the 16th century. The Reformation was stirring. Luther thundered from Wittenberg. The Church, besieged by heresy, would not welcome a cosmology that seemed to unseat mankind from God's privileged center. So Copernicus chose discretion. He drafted a small manuscript, the Commentariolus, and circulated it privately among mathematicians. Word spread quietly through Europe's intellectual corridors. Some dismissed it as fantasy, others as genius cloaked in madness. Decades later, a young student named Georg Joachim Rheticus would read those pages and set out across frozen rivers to find the reclusive canon himself. But in 1514, none of that was known. Only the monk and his candle knew the extent of the challenge he was crafting. In a world still ruled by dogma, he was preparing an argument that could not be silenced by fire or decree, because it was written not in defiance but in mathematics, the universal language even bishops feared to misunderstand. Night after night he refined his calculations, aligning observation with a theory until the motions of the planets obeyed his equations like notes on a staff. It would take him nearly 30 years to gather the courage to publish, to allow De Revolutionibus Orbium Coelestium to reach beyond these walls. But in this frozen Polish winter, the seed of that revolution was already alive. A monk, obedient in posture, rebellious in thought, had begun to move the earth. By the time Copernicus reached his 50th year, the quiet coastal town of Frombork had become both his refuge and his prison. The cathedral bells marked the hours as precisely as his celestial charts, tolling for Mass, for Vespers, for the rhythm of a world he no longer believed was still. In the archives of the chapter house, he balanced ledgers and settled disputes among canons, the dutiful servant of his diocese. Yet even amid such mundane obligations, the heavens tugged at him. Each clear night he climbed the worn stone stairs to his observation platform, carrying a brass astrolabe and a notebook, the instruments of a solitary war against ignorance. From there, he watched Jupiter's stately drift and Venus's shimmer near the dawn. He could not measure angles with precision. His tools were primitive, but the pattern was unmistakable. The earth itself, not the sun, was the wanderer. To see it was to feel the world lurch beneath one's feet, as if the very floor of creation had shifted. Still, Copernicus kept silent. He understood the memory of Jan Hus, burned for lesser heresies, and the wrath that had crushed Galileo's predecessors. Better to let numbers speak softly. The bishop, who valued him as an administrator, asked no questions about his celestial habits. The villagers, who saw his candle glow in the tower until dawn, whispered that their cannon spoke to the stars, and perhaps he did. The language of his equations became a prayer more faithful than liturgy, one that sought not redemption, but understanding. But even the most secret ideas eventually find an audience. In 1539, a Lutheran scholar from Wittenberg, Georg Joachim Rheticus, appeared at the gates of Frombork, having heard rumors of an old astronomer who claimed the sun, not the earth, was the heart of motion. Rheticus was everything Copernicus was not: young, energetic, unafraid. He carried with him the spirit of the Reformation, the belief that truth could challenge authority, that Scripture itself could withstand scrutiny. At first, Copernicus hesitated to receive him. The Church watched outsiders closely, and Lutheran sympathies could taint a man's name. But curiosity triumphed. Over months of shared calculations, Rheticus became the first disciple of the heliocentric creed. He saw in Copernicus's diagrams the geometry of liberation, a universe governed by logic, not decree. Rheticus urged him to publish, to let the world see what he had hidden for decades. "If God gave you these numbers," the young scholar said, "he did not mean for them to die in a drawer." Reluctantly, Copernicus agreed, allowing Rheticus to prepare a summary, the Narratio Prima, which would circulate among Europe's intellectual elite. For the first time, the idea of a sun-centered universe emerged from the shadows. The response was bewilderment and awe. Some hailed it as the rebirth of ancient wisdom. Others condemned it as blasphemy. But the tide had turned. The old canon who had spent a lifetime whispering to the stars now found his words echoing through universities, across borders, into the heart of the very church he served. The revolution had begun, not with fire, but with geometry. By 1540, the idea had escaped its author's control. What Rheticus had brought to Wittenberg spread like ink in water through Europe's universities. Philosophers in Padua and Paris argued over its implications. Jesuits debated whether the mathematical elegance of heliocentrism could coexist with Scripture. In Nuremberg, printers requested the manuscript of Copernicus's treatise, but he hesitated to send it. He knew what publication meant: exposure, scrutiny, perhaps condemnation. For 30 years he had guarded his findings as a monk guards a confession, not out of fear alone, but a sense of reverence. To declare the earth in motion was to move man from the center of creation, to reorder the cosmic hierarchy upon which faith and empire rested. Yet the pressure mounted. Letters arrived from Cardinal Schönberg and Tiedemann Giese, friends and churchmen who urged him to finish his book. They assured him that mathematics was no heresy, and that numbers, being neutral, could not offend God. Perhaps, they said, his system would clarify the divine mechanism of the heavens. Copernicus wanted to believe them. At nights he walked the frozen shore of the Baltic, watching the stars wheel overhead, and wondering how truth could be both so simple and so dangerous. He revised his tables, redrew his orbits, and compiled his life's work into a manuscript he called De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres. It was a book written in the language of precision but burning with quiet defiance. Its pages described a cosmos governed by motion and harmony, a mathematical hymn to a creator whose order was not human-centered. Still, the author hesitated to let go. Even as the ink dried, his hand trembled. He was a churchman, not a rebel. Yet he knew his calculations would place him among those who challenged the throne of heaven itself. When the manuscript finally reached the press in Nuremberg in 1543, it arrived with an interpreter the author had not chosen. Andreas Osiander, a theologian tasked with overseeing its printing, feared the book's theological impact. Without Copernicus's consent, he penned a pseudonymous preface claiming the heliocentric system was merely a mathematical convenience, not a statement of truth. It was a protective veil and a betrayal. Osiander believed that if the book appeared as speculation, the Church might tolerate it. In reality, the preface neutered its revolutionary force, making its author seem timid. But history had its own sense of timing. As the first printed copies arrived in Frombork, Copernicus lay dying, his health broken by a stroke. He held one of those volumes in his hands. Witnesses say he was unconscious when the book was placed beside him, and thus saw his life's work only in its final moment. He died that day, the old monk who had redrawn the sky. In the years to come, his work spread quietly but irrevocably. Astronomers in Italy, Poland, and England copied its diagrams. Professors whispered its name to students who would later teach Kepler, Galileo, and Newton. The Church took decades to notice, and when it did, it was too late. The universe had already moved. The monk who had challenged the Church with math was gone, but his numbers had become immortal, circling forever in the minds of those who dared to look up and ask if the center was ever truly here. In the decades that followed Copernicus's death, his ideas drifted across Europe like embers carried by the wind, glowing faintly, difficult to extinguish. They found their way into the notebooks of young astronomers who sensed that the heavens might be simpler than Aristotle had claimed, that the truth might lie in circles and ratios rather than dogma. Among them was a fiery Dane named Tycho Brahe, whose brass instruments rose from an island fortress like the ribs of some great mechanical beast. Tycho did not yet believe the Earth moved, but he respected the precision Copernicus had demanded. He measured the skies night after night, determined to test the monk's geometry against the stubborn facts of the cosmos. His measurements would later pass to a quiet German mathematician named Johannes Kepler, a man haunted by poverty, religious wars, and the conviction that God's mind could be glimpsed through mathematics. Kepler's mother was accused of witchcraft. His own faith placed him on the margins of both Catholic and Protestant worlds. Yet, through those miseries, he found harmony in motion itself. The notion that planets traced not perfect circles but ellipses, their speeds changing like notes in a divine chord. Without Copernicus, such heresy would have been unthinkable. The heliocentric model had cracked the crystal spheres. Kepler smashed them entirely, revealing a universe held together by invisible laws rather than crystalline shells. Each discovery pushed the Church further from its accustomed center, forcing theologians to confront the possibility that man's place in creation was smaller, yet grander, than ever imagined. Then came Galileo Galilei, the Florentine mathematician who turned a newly invented telescope toward the heavens and saw, with his own eyes, what Copernicus had only deduced. He watched the moons of Jupiter circle their master, tiny confirmations of a truth that no decree could silence. Not all things revolved around Earth. Galileo read De Revolutionibus like scripture and proclaimed it openly, too openly. Where Copernicus had cloaked his revelations in numbers, Galileo announced them in Italian to crowds and princes, wielding the telescope as both weapon and sermon. The Church, now alert to the danger, reacted with fear. The Holy Office summoned him, pressed him to recant, and placed De Revolutionibus on the index of forbidden books. Yet the very need for censorship proved how far the idea had spread. even as Galileo bent his knee before the Inquisition, whispering that, nonetheless it moves, the heavens continued their patient, silent testimony. Copernicus's ghost lingered in those courtrooms, the humble canon who had dared to suggest that divine order was larger than human pride. Through Kepler's equations and Galileo's lenses, his math became the foundation of modern science. What had begun as a monk's private meditation on symmetry had evolved into a revolution of thought, one that would reach Newton, Einstein, and beyond. The monk who once feared to publish had, by restraint, ensured that his vision outlived empires. His challenge to the church had not been shouted from pulpits, but whispered from observatories, proving that truth, once measured, does not retreat. Centuries passed, and the world Copernicus had unsettled transformed beyond recognition. His name became a synonym for upheaval, a byword for any idea that reorders the human view of reality. The Copernican revolution, as later philosophers would call it, reached far beyond astronomy. It rewired the way man perceived himself, from a fixed spectator at the center of a divine stage to an actor adrift in a vast, indifferent cosmos. The irony was that Copernicus himself had not sought rebellion. He had wanted harmony, a geometry that honored God through clarity. Yet his insistence that observation and mathematics could reveal divine order more perfectly than tradition ever could was the real heresy. His book had moved from the shelves of monasteries to the desks of Enlightenment thinkers, Descartes, Kant, Voltaire, who drew from his example the courage to question not just the heavens, but all authority grounded in habit rather than evidence. By the 18th century, telescopes had grown powerful enough to confirm what Copernicus had only imagined. The sun, too, was moving, circling a galactic center, one star among billions. Humanity's stage kept expanding, each discovery another layer peeled away from the illusion of centrality. The church that once condemned his book eventually endorsed it as scientific truth, its theologians citing the courage of inquiry as proof of faith refined, not destroyed, by reason. Yet the real legacy of Copernicus was not his model, nor even the equations that described it, but the moral shift it demanded. That belief must bend to evidence, that humility before the cosmos is a form of worship. And so the story of the monk who challenged the church with math ends not in flames or trial, but in quiet vindication. His revolution was a whisper that became a roar, a solitary candle that set the firmament ablaze. Today, the instruments he once dreamed of, space telescopes, spectrographs, deep space probes, continue the work he began, tracing orbits not of 7 planets, but of countless worlds, each circling its own sun. In every astronomical image sent back from the void, there is an echo of that moment in a cold tower in Frombork, when a man looked up and realized the floor beneath him was turning. It is tempting to see Copernicus as a symbol of defiance, but that is too simple. He was not an iconoclast by choice, nor a rebel for rebellion's sake. He was a servant of truth, bound by vows both religious and intellectual, who found that the two were not enemies but reflections of the same mystery. His faith did not end where his equations began. It deepened there. To measure the heavens was to glimpse the divine mechanism, not a god of thunder and judgment, but of order and beauty. In this, his challenge to the church was also his gift to it, the reminder that creation's majesty is not diminished by understanding, but illuminated by it. From that realization grew the entire modern world, the sciences, the instruments, the restless curiosity that defines humanity. The monk's victory was never over the church, but over fear itself. And in that victory, he taught us that to question is not to doubt, but to believe more deeply in the miracle of reason. In the century after Copernicus, the embers of his revolution flared into a new age of reason. What began as celestial mathematics had become a universal language, a way to decode not only the heavens, but all of nature. In England, Isaac Newton sat at his desk surrounded by prisms, lenses, and manuscripts, building on the foundations Copernicus had laid. Newton's universe was not held together by divine command, but by an invisible force. Gravity, the silent thread binding planets to the sun. It was a system so complete that it seemed to replace God's intervention with law. Yet even Newton, the most rational of men, believed those laws were the handwriting of the Creator. The heliocentric model had done more than move Earth from the center. It had moved God from micromanager to architect. Across Europe, scholars from Paris to Padua followed the same path, applying mathematics to everything from the tides to the orbits of comets. The Copernican spark had become the scientific method: observation, hypothesis, verification, a creed of its own. For the first time, man felt he could predict the future, not through prophecy, but through calculation. Cathedrals of learning rose beside cathedrals of stone, and experiment replaced revelation as the highest form of worship. The monk who once measured stars from a frozen tower could never have imagined that his geometry would inspire entire nations to measure the world itself, to sail farther, to map more accurately, to turn inquiry into empire. But even progress casts shadows. The mechanistic universe Newton described, predictable, perfect, clock-like, comforted some and terrified others. If all was law, where was freedom? If the heavens moved by necessity, what became of grace? Theologians wrestled with these questions as universities slowly accepted Copernicanism not merely as hypothesis, but as reality. The Vatican's own observatories began to use heliocentric tables for navigation and calendar reform. Slowly, the idea that had once threatened faith became its tool. Yet the deeper revolution was philosophical: humanity's relationship with knowledge itself. Truth was no longer inherited. It was discovered. Authority could be tested, questioned, revised. The age of faith was yielding to the age of reason, not through rebellion, but through curiosity. The line from Copernicus to Newton was unbroken. Both had read the universe like scripture written in numbers, and both had found, beneath the poetry of faith, the symmetry of truth. The Church's fury, once white-hot, cooled into reluctant respect, for even it could not deny that the sun rose and set exactly as the monk's equations predicted. And in that reluctant acceptance began the modern world, a place where questions became holier than answers. By the 18th century, the Copernican revolution had leapt from observatories into the hearts of philosophers. It was no longer just a question of where the Earth stood in space, but where man stood in the order of existence. The thinkers of the Enlightenment, Descartes, Voltaire, Diderot, and above all, Immanuel Kant, saw in Copernicus not just an astronomer, but a prophet of intellectual courage. When Kant published his Critique of Pure Reason in 1781, he invoked Copernicus directly. Just as the monk had turned the heavens inside out by placing the sun at the center, Kant proposed to turn philosophy inside out by placing the mind at the center of knowledge. The world, he argued, does not shape us. We shape the world we perceive. It was the second Copernican revolution, a shift from cosmic order to consciousness itself. In this new light, every law of nature, every equation, every act of observation was no longer passive discovery, but participation. To know reality was to help construct it. The implications were immense. Art, politics, and science all absorbed this new confidence in human reason. Across Europe, men and women began to believe that the universe was knowable, that ignorance was a form of bondage, and that enlightenment, true enlightenment, came from daring to question everything. Copernicus's ghost walked the corridors of Parisian salons and Prussian academies, his quiet defiance reborn in the clatter of printing presses and the murmur of debate. But the Enlightenment's light was sharp as well as bright. By replacing divine revelation with human reason, philosophers inherited both power and peril. Voltaire mocked superstition but built new dogmas of logic in its place. Descartes declared, "I think, therefore I am." Yet his rational clarity often felt colder than faith. Still, behind all these voices lay the same courage that had guided a monk's quill in Frombork centuries before. The conviction that truth must be earned, not handed down. As kingdoms toppled and republics rose, the Copernican spirit infused the age's revolutions. The American founders cited the laws of nature and of nature's God, echoing the harmony between reason and faith that Copernicus had quietly embodied. The French Revolution, for all its chaos, proclaimed that enlightenment, the triumph of knowledge over ignorance, was humanity's rightful destiny. Even in their excesses, these upheavals bore his mark, the belief that order should arise from understanding, not authority. The stars that once confirmed divine hierarchy now symbolized human freedom, distant suns lighting the path of reason. And though the Enlightenment would fracture into skepticism and romanticism, the core remained, a universe intelligible to the human mind, mapped not by priests, but by thinkers who stood on the shoulders of a monk who once dared to say the earth moves. By the dawn of the 19th century, the war between science and faith had begun to cool into an uneasy truce. The Enlightenment had stripped the heavens of angels, but it had not erased wonder. The telescope and the microscope alike revealed beauty too intricate to be mere accident. Even as industrial smoke darkened Europe's skies, the same curiosity that had driven Copernicus lit the lamps of a new generation of thinkers, theologians who refused to see reason as an enemy of belief. In Rome, the Jesuits maintained observatories, charting comets and eclipses with the same rigor as their Protestant counterparts. In England, clerical astronomers like William Whewell and John Herschel wrote that to measure creation was to glorify its maker. Gradually, the Church began to reinterpret the Scriptures not as a celestial map, but as moral truth. The literalism that had once demanded a stationary earth gave way to metaphor. "The Bible," one theologian wrote, "teaches how to go to heaven, not how the heavens go." It was a quiet revolution, the healing of a rift 4 centuries old. The monk who had once feared to publish his equations had, without knowing it, begun a conversation that would outlive him, a dialogue between mystery and measurement that defined the modern age. And yet, reconciliation came not through decree, but through humility. Scientists discovered that their precision, for all its brilliance, still met mystery at every horizon. Newton's clockwork cosmos began to tremble under the pressures of new discoveries. Electricity, magnetism, radiation. The more mankind saw, the more it realized how little it truly understood. Faith, once cornered, found room to breathe in the gaps that science could not fill, not as retreat, but as perspective. To many, Copernicus now symbolized not defiance but balance, a believer who trusted both scripture and mathematics, who saw no contradiction in seeking divine truth through the structure of the stars. The Vatican itself would one day restore his honor, erecting statues in his name, citing his work as evidence that truth and faith were not enemies but co-conspirators. In this gradual reconciliation, Europe rediscovered its intellectual soul, the belief that understanding creation is itself an act of reverence. The Copernican revolution, once a wound, became a bridge. The same geometry that had exiled the earth from the center now placed humanity within a grander harmony, not beneath the heavens, but among them. The 19th and 20th centuries carried Copernicus's vision farther than even his boldest imagination could have reached. What had begun as a rearrangement of the solar system became a redefinition of reality itself. In 1838, Friedrich Bessel measured the first stellar parallax, the minute wobble of a star's position caused by Earth's orbit, proving beyond all doubt that the planet truly moved through space. The monk's geometry, once dismissed as abstraction, was confirmed by light itself. Then came the discovery that our sun was not fixed in place, but orbiting the center of a vast galaxy, a whirlpool of hundreds of billions of stars. The Milky Way, once thought to encompass all creation, was revealed as only one among countless others. Every generation since Copernicus had inherited a smaller Earth and a larger universe. By the early 1900s, astronomers like Edwin Hubble stood on mountain peaks and captured the faint glow of distant galaxies, expanding the boundaries of existence to infinity. The Copernican principle, as it came to be called, declared that there was nothing special about our position in the cosmos. No center, no chosen vantage point, only endless motion, governed by the same laws everywhere. For some, this realization was liberation. For others, disquiet. To be one world among billions was to feel both insignificant and eternal, a paradox that haunted philosophers and poets alike. Then, as if to complete the circle, physics turned inward. Einstein's theory of relativity bent space and time into a single fabric, revealing that even the laws of the cosmos depended on the observer's frame of reference. A deeper echo of the shift Copernicus had begun. Just as he had displaced Earth from the center, Einstein displaced the illusion of absolute perspective. The universe had no privileged viewpoint. Truth existed only through relationship. In that revelation, the Copernican idea reached its most profound expression. From Newton's orbits to quantum uncertainty, every discovery reaffirmed the same principle. The cosmos is vast, impartial, yet astonishingly intelligible. Humanity, once central and immobile, had become an instrument of perception, the way the universe observes itself. The theological shock that once split Europe had mellowed into philosophical wonder. The heavens were no longer a stage for divine drama, but a laboratory of light, energy, and time. Yet the awe remained the same. Scientists, priests, and poets alike stood beneath the stars, feeling the same vertigo Copernicus must have felt in that tower centuries before. The Earth moved, yes, but so did everything else. The center was everywhere and nowhere. In the modern age, the legacy of Copernicus is no longer confined to observatories or dusty manuscripts. It lives in the very way we see ourselves. Every photograph from the Hubble telescope, every image of galaxies colliding or nebulae giving birth to stars, is a silent continuation of his rebellion. When astronauts looked back from the moon and saw the Earth, a blue, fragile sphere suspended in blackness, humanity witnessed, for the first time, what Copernicus had only imagined. That image, Earthrise, taken in 1968, was perhaps the most profound theological statement ever captured by a camera. The planet that had once been the center of the universe now appeared as a single, borderless home. For centuries, the Church had feared that removing man from the cosmic center would strip life of meaning. Instead, it revealed a deeper truth, that significance does not depend on location, but on consciousness. To understand the universe is to belong to it. The monk's numbers had become a mirror in which humanity could finally see itself without illusion. Small, yes, but capable of infinite comprehension. And yet, the revolution never truly ended. Each century seems to rediscover its own version of Copernicus. Someone who dares to look at the accepted order and whisper, "What if this is wrong?" From Darwin to Einstein, from Turing to Hawking, every age produces minds who challenge the boundaries of belief with reason, and belief reshapes itself in response. In our time, the telescopes have grown digital and the observatories orbit above the clouds, but the questions remain the same. Are we alone? Why is there something rather than nothing? What place does consciousness hold in a universe ruled by physics? The answers still evade us, but the act of asking, that restless curiosity, is the true inheritance of the monk from Turin. His revolution was never about astronomy alone. It was about courage. The courage to doubt without despair. To measure the heavens, not to defy God, but to understand his language. If the 1500s were the dawn of reason, then today we stand at its twilight, with machines learning, stars dying, and new worlds awakening light years away. All echoes of that single moment when a quiet scholar raised his eyes from his calculations and realized, the Earth moves.